Hello and welcome to another video. This is Cracking the Cryptic app, Fog of War pack, puzzle number 5. ProFOGation. The rules are: Fog of War. Correctly placed digits clear the fog around them. Classic. Every row, column, and box must have all numbers from 1 to 9 exactly once. Thermometer. Numbers must increase as they move along thermometers, starting at the bulb. There is also a custom rule. The central cell is a bulb with 8 lines emerging. Okay, let's get this started. So this is the central cell that it's talking about, and we can indeed see that it has 8 thermometers emerging. We don't know how long either of them are, or if they curve, maybe it goes like this, and then goes down or something. So we have a lot of possible options. One thing that we can immediately realize, though, is that within a thermometer, the bulb has the lowest possible value, right? So the number 1 can never show up in the body of a thermometer. It can only show up within the bulb, because if it shows up in the body, then the bulb would have to be smaller than that number, so it would have to be a 0, which is impossible. Let's make an observation. Because from this central square there are 8 branching thermometers, we can see that all of these squares around the central square are on the body of a thermometer, and as we've previously concluded, the body cannot contain a 1. So since a 1 has to show up in this box, it must be the central value, so that must be a 1. And that is how we place the first value of this Sudoku. But before we do that, let's just fill in every possible value for every other square, just so that it's a bit easier for us. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Since we have an 8 here already, let's just make sure to clean the 8s up. Okay, so this is a 1. Perfect. Now, what do we see? The number 9 cannot show up on the body of any thermometer that continues, right? So it can only show up as the last entry in a thermometer. And we can see that all of these thermometers go up for at least one more square, right? Nothing here, actually, but here, here. They all continue onwards. So since a 9 must show up in this box, it can only possibly show up here. All right. Now, let's start counting. So 1, 2, 3, 4, 5, 6, 7. So that's a 7 as the maximal value of this square right here. As the minimal value, sorry, I apologize. So the minimal value of this thermometer is if it starts from a 1, and then each value afterwards is a consecutive value. So 1, 2, 3, 4, 5, 6, 7. That's the minimal value of this thermometer. But it also happens to be the maximal value, because no number greater than 7 can possibly be here because of the 8 and the 9. And since the minimal and maximal value match, then that means that that is in fact the value of this square right here. And that is because that is the reason why when we count downwards, this is the only possible configuration where we can fit all the other digits of the thermometer. Okay, let's keep going. This unlocked a bunch of new stuff, so we have to take some time to figure out what happened. Okay, so over here we see that this starts with the minimum of 5, 6, 7, 8. We don't know if it goes anywhere else, but oh, there is no 8 here. So 5, 6, 7, making this a 9. So again, the lowest possible value that this could take is identical with its highest possible value, And since its value must lie between those two, between the lowest and highest possible, and they match, then indeed this is a 9, making this a 7, this is a 6, and so this is a 5. Since an 8 was revealed and newly revealed digits don't get cleared from the notes, we have to manually do this. Okay, therefore this is a 7, making this, is this a triple? It isn't. Oh, that's too bad. Was this 8? No, this 8 was here already. So what can we do here? We should probably start clearing the thermometers. Basically, for example, for here, the minimal value is a 3, meaning that this cannot possibly be a 2 or a 3. And the maximal value is 8, meaning that this cannot be an 8. And then we should do that everywhere, meaning that this cannot be a 1 or a 2, or a 3 for that matter. And because the maximal value is 8, the 8 cannot be here. Now, 4, 6, 8, 9, we see that we don't know actually how it curls. It could just, or if it could be just 8, 9 here, so we should not rush into this conclusion at all. And over here, so this cannot be a 2 or a 3, and this could not be a 1 or a 2 or a 3, and over here we cannot have 1 or a 2. Is that everything? So let's see if something maybe opened up. Let's just check all the digits and all the places where they can be. Maybe something revealed itself. So we're checking the 2s now. Nothing is immediately apparent. Let's check the 3s. Nothing yet. Oh wait, I see something here actually. So an 8 can only be here inside this box, so this is an 8. All right, so that means that this is a 9. Okay, so that does reveal some more stuff. Basically the highest possible value here is a 7, and there is a pair here of 4, 6. So let's just get rid of the 4 and 6, my bad. This is 4, 6. And the highest value here is a 7, meaning that this cannot be an 8 or a 7, and then this cannot be a 7 or a 6, and this cannot be 1, 2, or a 3. Okay. What else do we have? So something here revealed itself, it seems, but this is a bulb that branches into 2 areas. So this cannot be an 8, right? Because this cannot contain a 9. It also cannot be a 7, because both of these are 8 and it branches into them. And I'll hold off from filling in any other value. Let's now again go through each value and see if maybe we have something that we can use. So 1, oh, we have a pair here actually. There is a 4, 8 pair. So 4 and 8, making this 1, 2, 3. All right. So a 1 cannot be here because they're both in the body of a bulb, and that means that a 1 has to be here. All right. So an 8 cannot be here because there is no number greater than 8 here, so that's a 4, making this a 3, and this cannot be a 1. Oops, this cannot be a 1 Oh my god, can I click, please? This cannot be a 1. And since this is a pair of 2 and 3, 2 and 3 cannot be there either. And that's the 8. Okay. So, what else do we have? Let's go back to checking the 1s. The 1s are not useful again. So, let's check the 2. Nothing useful, I think. The 3. Oh, we see something actually. There is a 5-6 pair over here. And that means that there is no 5-6 in this row. So where was I? I was at the 3, right? 3, 4. Okay, and then there's the 5. Okay, and then there's the 6. So the 6 has to be here. All right. What did it do? Okay, 6. Making this not be a 4 or a 5. So let's start checking from the 3 onwards. So 3, 4, 5. Okay, and then 6 again. Okay, 7. So a 7 is either here or here, making sure that a 7 cannot be here. All right, that's the 7. And then there's the 8. And finally, the 9. Okay. Now let's check each of the remaining thermometers just to make sure that we're not missing something super obvious. So in this one, this seems fine. 5, 6, 7, this seems fine. Oh, okay, so in this one, obviously, we cannot have number greater than, yeah, so greater than 4. So this is a 3. And since this is a 4-5 pair, then this is 7. And this is also 7. There cannot be a 5 over here either. And now we keep going. So we've placed the 3. I've placed 7. Oh, this is silly. So this cannot be a 5, obviously, because the only values here are 2 and 3. So this cannot be a 5, and it also cannot be a 2, in fact, because if it was a 2, both of these cells would contain a 3. So this has to be a 1. Okay, so this cannot be a 2, making this a 2. So this is an 8, and then this is 5. Okay, so this is a 9. This cannot be a 7 because the highest value here is a 5. So this cannot be 7, 6, or a 5. It also cannot be a 4 because we see it curls upwards. And that means that because it was 4, then this would be a 5, and then nothing would be here. So it has to be a 2. So now we see that it is in fact going all the way there. So it also cannot be a 5 for the same reason. So this cannot be a 5. Can this be a 5? Nope. Because it would be 5, 8, and then there will be nothing here. So this cannot be a 5 either. Making that a free 4 pair. So free 4. And that ensures that over here we don't have a 5. Since this is 4, 9, that means that this is a free. And so this is a free. And the 1 cannot be over here. So the only place the 1 can be is over here. Okay. Obviously, since this is 5, 8, this has to be the 5, and then this has to be the 8, and this has to be the 4, and this lower value has to be the 3. And then we have a 4 here, a 5 here, 6, 7, and this over here is an 8. And this is a 5, 5, 2. Okay, that's the ones. 2. Oh, there's a 6 here. All right, so 3. 4, 5. Oh, there's a 1 over here. I didn't notice it. So obviously this cannot be a 2 or a 3 because the lowest value here is 4. So this has to be the 9. So this is 4, 5, 6. So this is 7, 2, and this is 3. And now this should more or less be resolved. It will just take a little bit of time to unravel everything, but the puzzle is more or less finished. So this is a 3, 8, 7, 2, 3, 2, 3, 6, 9, 1, 8, 6, 1, 4, 6, and 4, and 2. All right, that is one fun puzzle. Thank you guys for watching, and see you in the next one.